Hi, Algebra 3 students. We are going to be looking at the next set of notes in your Know Your Parents note packet. So last video, we took notes on this thing called Know Your Parents, and we looked at the three big parent functions: square root, absolute value, and your quadratic family. So where you need to be here is this thing called the translation of parent functions. Okay, you can see that I've done this first one for you. But we're going to talk about how I got that. And so first thing I've asked you to do is this is no longer just the parent function. This is going to be looking at, we're going to move these functions around. So I've rewritten it here, and we're going to be looking at f of x equals x squared minus 4. So the first thing you have to do is decide what parent function is it. Is it quadratic, square root, or absolute value? Well, this guy right here tells you that it's the square root function, which means it's the u. So now you have to go back to that parent function and figure out all those critical points and those characteristics. So we know that the parent function that is quadratic has a vertex at 0, 0. And then I went to the right one, up one, to get my nice point there. Then I went to the left one, up one, to get my nice point there. We also know that it is the U shape, and my U looks something like that, okay? But if you look at your directions, it's not x squared, it's x squared minus 4. And so what does that minus 4 do to the graph? Well, that's what we're going to try to find out. So we're going to go back to Desmos. So everybody open up your Desmos screen. It looks something like this, okay? And I'll erase this so we can see how I did this. In Desmos, we're going to type in the equation y equals x squared minus 4 to investigate what happens. But first, let's put in the parent function. Okay, oops, there's that parent function. Vertex, critical points, excellent. Okay, let's plug in that y equals x squared minus, oops, got to drop that down. Sorry, guys. Drop your cursor when you do that, minus 4. What happened to the original parent function? What's red was original, what's blue is now how it's been transformed or moved. And so let's take a look at this blue graph. That vertex is no longer at 0, 0. It's down here at negative 4. But take a look at this. I went to the right one, up one, and there is my new nice lattice point. Then I went to the left one, up one, and there is the next nice lattice point. So let's go back to our page and put that in. Okay, please use a separate color. Okay, please use that separate color. And we're going to put this in. And so you're going to come down here to negative 4, but I went to the right one, up one for that next critical point, and to the left one, up one. And now I'm going to draw my U again. Now my U is definitely not as perfect as Desmos, but you're definitely going to get that shape. Oops, and I said to dash it. I completely forgot. But what I want on these graphs is I want you to be able to look at the parent function and then how you transformed it, okay? So your notes should look something like this. All right, let's go to the next one. Okay, we have to figure out again what parent function it is. Ooh, I see a square root. So I know my parent function is a square root. So I know that it had this first point at 0, 0. Then I went to the right one, up one. That was its characteristics. I could also go over 4, okay, and up 2, because the square root of 4 is 2. Square root of 9 is 3, and so on and so forth. And it was the swoosh, remember? It looked like this. But I don't have just the parent function. I have the parent function, x squared, or sorry, square root of x, now plus 2. Okay, let's go back to Desmos and see what is happening. All right. All right, when I share this, just hit the X on the side, guys, and it takes care of those graphs. So let's type in y equals, and remember square root is SQRT X. We know what this is, and if you guys can't see it, it's just because it's hidden there. There it is. You just got to pull your mouse and grab the screen. But we know it's not just the square root of x. So let's do y equals SQRT x. Now you have to move the cursor to the right. You have to get it out from underneath the sign, plus 2. What just happened? Okay, well, I went up 2, and my vertex is no longer 0, 0. It's here at 0, 2, but I went to the right and up 1, okay, from that point. So I went to the right 1 and up 1. All right, let's go back to our notes and put that one in. Again, using a different color. So remember that first point is no longer at 0, 0. I moved it up 2. Now everything else stayed the same. I still went over 1, up 1 for that next point. And we could see that if I plugged in 4 and it would still be, that next point would be up here at 4. And then again, this time I will remember, I want you to dash your new function. Okay, all right. Let's come over here to this guy. Again, you always have to decide first what parent function you have. Well, this is nice. I have the absolute value. And so absolute value, we had a vertex at 0, 0. I went up 1 to the right 1 to the left 1, just like that. And I made a V. Ooh, my V is not so great here, guys. Okay, not so great. It kind of looks like a U, but that's a V. All right, let's go back to Desmos and see what happens when I subtract 3. At this point, I'm really hoping you are seeing a pattern with what the -4 and the +2 did to the other two parent functions. Make a conjecture here and say, when I type in the absolute value of x, we know it looks like this. What do you think is going to happen when we type in the absolute value of x -3? Where do you think that vertex is going to go? It went down 3. Interesting. Again, our next critical point, that next nice lattice point is still there, and it's still there. We haven't changed where those moved. We've just moved the vertex down. Okay. Let's put this one in. So it was -3, so I came down here. My new vertex is down here at -3. I went up, right 1, up 1, left 1. I'm going to try to make, if I were really doing this really super nice, I would be using a ruler, guys. But all my rulers are at school, so I apologize. Okay, now here's the part that I really want you guys to think about, is the conclusion. What does it mean when you add or subtract a number outside of the grouping symbol? So the x squared, the square root, and the absolute value means that's the grouping symbol. It's not in the grouping symbol, and you'll see what I mean here in a minute. But if it is being, so if a number is added to a parent function, the first point or the vertex, okay, the vertex or the first point, if we're talking square root, moves up. So we have added and up. But what happens if we subtracted a number? Like here, -4 and -3. We subtracted 4, subtracted 3. What happened to that vertex? Okay, so if a number is subtracted to a parent function, then the vertex, I forgot the there, moves down. Okay, let me see that. Okay, guys, that's what it looks like. So if a number is added to a parent function, then the vertex moves up. If a number is subtracted, okay, to a parent function, then it moves down. Simple, right? Okay, so let's try part 2. There's always going to be a part 2 and on all of your notes. So here's part 2. Where's that -2 now? Or the +4 or the +2? This is what I mean by inside the grouping symbol. I want you guys to think about, what do you think is going to happen now that I move the numbers to the inside of that grouping symbol? want you just to take a look and think about it. In the meantime, let's put in our parent function. Ooh, this is absolute value, so I got to make my v. Put in my points. Put in my critical points. And, all right, guys, I'm going to be, I don't even know if I have a nice ruler. I'm going to make it look super V-like. We'll see. Ooh, maybe I will not. Ah, I got it. Okay, there we go. Ooh, even though I missed my critical point. There's our V, okay? Conjecture right now. Pause the video and say, I think the -2 will do this to the graph. Pause it now and try it. Okay, back to Desmos we go. All right, we already have the absolute value here, but now I have this -2 on the inside. Huh. What happened to the graph when I put the -2 on the inside of that grouping symbol? Well, our vertex is now over here. My critical points are still to the right one, up one, or to the left one, up one. So let's go put that in. Interesting, huh? So right now, my new point is right here. My next critical points are right there. Now, remember to dash this so you can remember which one was the parent and which one was the dashed. Interesting. Okay. The video for translating parents is going to come to an end here. You need to do this example and this example on your own, and you need to write the conclusion. At that point, and you come back to class, we're going to talk about what you wrote for your conclusion. I want to see how you interpret this. Good luck, Algebra 3, and we'll see what happens. Okay? All right, see you guys in class.